Good?
Yeah.
So this is connecting 3 light bulbs or 3 loads in parallel. And as you've noticed, we have divided the hot line into 3 lines, one going to the first light bulb, second light bulb, and third light bulb. And the neutral is coming from each one of them connected together to the same line. So we have our hot and neutral. We already checked for continuity. So the first thing I would like to check is the total resistance. And if I check the resistance between one light bulb, it's going to give me the total resistance for 3 of them. So it's, this way, it's take the light bulb by itself, then measure the resistance. So for this light bulb, I got 25 by itself from the previous experiment, and for this one 200, and this is 200. So the total should be less than 20. And I'll check that here, and I'm getting 18.8 as the total resistance, even though this is 200, 220 ohms. I will check the voltage now, and you'll see they will all burn bright because they're getting the same voltage. So the voltage over there is 118. If I go over here and check the voltage, it should be 118, and here is 118, and here is also 118. So they're all getting the same line voltage. Okay, what about the amperage? I'll set the multimeter on amperage, and I will check the amperage going to this light bulb, and I got 0.31, and I got this one as 0.05, and the other one is 0.05. So between 0.05 and 0.05, and this one, which is 31, I should be getting something around 32, and that's the total amperage. And for here, yeah, I got actually 0.42 for total amperage. So it kind of makes sense to add them all together. We see it divided. And since this light bulb has lower resistance, it will draw more amperage, which kind of makes sense here if I look at the amperage. I can get also the total over here as well, which is 0.42 amps. That's for total. And in one of the questions in the lab, I was asking you, how do you measure small resistance using the clip-on meter? So one of the ways to do it is to kind of make a loop. So you can have the clip-on going in two loops instead of one, and you'll get a better rating. So now I get double, which is 0.83. So I can divide that by 2, the number of loops, and I'll get the amperage draw even if it's still small. It's a very useful technique to have when you have a very small amperage draw and you're getting 0 in the multimeter. So resistance did drop, and it's lower than the lowest one. This one was 18, that was 20, so the total was 18. The amperage did add up, and the voltage remained the same, and you can see all the light bulbs are burning the same way, the way they're supposed to. Okay, good.